Okay, this is lesson 11. And this is section 1.2 from the book. As I mentioned, I jumped around so that I got all the computational stuff out of the way in homeworks 1 through 10. The book actually just jumps right into graphing. And I wanted to get us really proficient with computations first, making sure we can do those things smoothly, and then just focus on the graph and not have to worry about fractions and other things and getting familiar with that on the fly. So we got all the arithmetic stuff out of the way, and now we're going to start graphing, starting with what is called the Cartesian coordinate system. That's a formal name, you don't really need to know it. More often they'll just say a graph. Oops, this is just a header, and I'm going to draw it. So what you're going to have is a vertical axis, a horizontal axis. This is a number line going from negative to positive. This is another number line going vertically from negative to positive. And formally they're supposed to, or you're supposed to, put arrows on the positive end, the direction of increasing values. So x with an arrow that way means it's increasing in that direction. Y with an arrow there means it's increasing in the up direction. And then you mark off tick marks, just like we did with number lines, except that we have a horizontal and vertical number line, and they're called axes. And this is called the x-axis, this is called the y-axis. We will change the variables, so maybe that'll be called the t-axis, maybe that'll be called the p-axis in the future. Generically, we can even call them horizontal or vertical axes. But for now, let's just stick with x and y. Draw an arrow. These are called axes. I think I mentioned it, but those are called tick marks. If you're doing anything on lined paper, don't write this down. This is me just making sure you have your binder paper, and you're going to do some graphs on it, and so you're going to get your pen, and you're going to draw some axes to do your homework for graphing, and on your exam too probably you might be using binder paper for that. Don't just assume that I know the lines of the paper are going to be your tick marks. Draw in those tick marks clearly, and you're going to label them always. Well, yeah. And so a lot of times you use integers for that. Sometimes you don't. Sometimes later on we're going to skip, we're going to jump integers. Sometimes you could use fractions if it was really detailed points involving fractions. But just make sure you put in the tick marks so I know where they are when you do your homework and quizzes and exams. Okay, what else? The origin, where the axes meet. That is called the origin. What else I got? Okay, and we're ready to talk about what that's used for. That's used to graph points given in the form of an ordered pair. An ordered pair is a pair of real numbers. They could be decimals, they could be ugly numbers, they could be integers. A lot of times they will be integers, but technically they could be any real number. A pair of real numbers that represent a point on your Cartesian coordinate system or on a two-dimensional graph. The two values are called coordinates. And let's look at one. So for an ordered pair designating a point, you have other situations where you have pairs of numbers, but to make sure it's clear that this is going to be a point on the graph, they'll put it in a set of parentheses separated by a comma. And they'll have one real number there. It may not be an integer, but I'm going to stick with nice round integers. So you have two numbers separated by a comma. The first number is the horizontal or x coordinate. Again, if it's labeled differently than x, if it's t, it'll be called the t-coordinate. But for now, again, let's stick with x and y. So your first number is the x-coordinate. The second number, the -2, is going to be your y-coordinate. Or more generically, that'll be your horizontal coordinate, that'll be your vertical coordinate. Okay, and I wrote it so big. I want some room because I want to actually graph this. Okay, let me just make it smaller. Okay, and you have the notes there, x-coordinate, y-coordinate, leave that. I do want to note that sometimes when you have more than one point, sometimes it will designate it with a letter. It'll just make it convenient for you to label it when you do your graph. I'm going to graph this point. As I said, this represents a point. Let me draw that basically, but a smaller version of it, because I'm not on a small side of room. X, Y, 1, 2, 3, 4. Sometimes if your tick marks represent integers, you don't need to label them necessarily. If they're deviate from that, you definitely need to label it. But here, if it's just generic like that, we can assume that each space is 1 apart. And so we're going to plot this point now. So, as I mentioned, the 3 is the x-coordinate. That's where you're going along the x. And actually, let me label it so we can be clear. That's 1, 2, 3. Right there is an x-coordinate of 3. So we're going to focus right there. 4, -1, -2, -3, -4. Okay, your y-coordinate is a -2. And so you're looking along the y-axis. Again, it's a number line with -1 there, -2 right there, -3, -4, 1, 2, 3, 4. So to plot this point, we're going to be doing many points. And you want to go 3 along the x. So right here's your x, and +1, +2, +3, right there. Now you're not going to put a point there because we need to incorporate the y-coordinate as well. This is not 2 separate points. It's 1 point designated by a pair of numbers. So next you go y is -2. Here's your y, +1, +2 going up. But no, we want to go -2. So -1, -2 right there. Right there. And you're not putting a point there and another point there. You're finding where they meet. Right there is the point in question. And if you have multiple points going on, then they want you to label it. You can either label it with 3, -2 right next to it, so they know the precise coordinates of that where that point is precisely placed. Or if they give you a letter to designate it, why don't we just go with a letter? So that's what it's there for convenience of us labeling that point P, because you're going to be doing several points on the same graph. And we'll do that now. We'll do an example. Plot the following points. So we're going to point A is 2, 3. B is -4, -1. C is -3, +2. D is 0, -2. And E is going to be 3.3, -2.8. So I'm going to throw a few decimals at you just so you can get an idea of where to place it. You're just going to eyeball it and estimate where you think it is. For instance, 3.3, we're going to be placing it between 3 and 4. Not quite halfway, closer to 3 than to 4. So right now I'm going to draw a big set of axes. I do want you to do this on your own first. Think about where these points go. You can hold off on E if you're not comfortable with that yet. But you should be able to do A, B, C, and D. I do want to make a special note that you do need to be careful with D. Whenever there's a 0 on there, it means it's going to be on one of the axes, and for some reason that 0 trips people up and they put it on the wrong axes occasionally. So when there's a 0 as one of your coordinates, just be extra careful and really think about it. think the graphs that I give you in your homework goes to 5 and -5, so I'll stick with that. We will have to use other much wider ranges eventually, but you're just getting familiar with the concept of plotting points. We're going to stick in this area here, where it goes from -5 to 5 along there, and -5 to 5 along the y-axis as well. Okay, pause it here and see if you can plot at least A through D, and maybe E if you want to take a stab at it. Okay, I'm going to start, but again, pause it, go through it carefully, and then confirm if we got the same points or we place it in the same place. First one, A, 2 along the X, 3 along the Y. Here's your X, we're going to go there. You don't need to mark it like this is me illustrating it to you guys at home. Positive 3, watch your signs, that's 1, 2, 3 along the Y, right there. And so we're looking for where these meet. This horizontal line right here is all the points that have Y coordinate equal to 3. This vertical line I'm drawing here contains all the points that have X coordinate 2. And the point that specifically has X coordinate 2 and Y coordinate 3 is where those lines would intersect. And you don't have to draw all of that every time. You just to make sure you place that point correctly. Again, 2, 3 is a single point. You're not putting a point in there and a point in there. I'm putting arrows there to indicate that we're going to look where they meet up essentially. Okay, label it. So we're going to have 5 points on the board, and we've got to make sure we distinguish it. We know which one is which. You don't need to label it with a coordinate since they gave us letters designated the points, so I'll label it with an A. Just put an A nearby it. Okay. -4, -1. -4 is your X, -1 is your Y. So I'm going to go -4 along the X right here. -1, -2, -3, -4. -1 along the Y. -1 is right there. So where do these meet up? Right there. B. I'm going to go a little bit quicker. Well, let's see. -3, +2. So I'm going to start here and just go -3 along the X. And then +2 along the Y means I'm going to go up 2. So I can go that way where I just count from the origin. And I just do my X, -3 first. And then Y is 2, meaning I'm going to go up 2. The same way I'll do 2 up from there. Okay, and that's my C. And then D, like I said, where is 0, -2? Sometimes people, I mentioned people get this one wrong a lot. Sometimes people put it right there on the x-axis. That is not correct. That would be an x coordinate of -2, and I don't. I have an x coordinate of 0 and a y coordinate of -2. So, here's the 1s, here's the 2s, here's the -1s. So 0 is right along here. So it is anything on this axis here. So this 0 means it'll be on the y-axis. The y could be anything. The y could be 1, it could be 5, it could be -5, it could be -4. But your x stays on 0. So again, moving left and right, you stay right there on x equals 0. They don't label it, but that's like an x equals 0 there. So you're going to stay on the vertical axis for this one. And where you're going to go along that vertical axis? Well, -2 is what tells you. So we're going to stay on 0 there, and we're going to go -2 along the y. Right there is D. Okay, last one, decimals. Let's just eyeball where we think it's going to be roughly. 3.3 along the x. That's between 3 and 4. Specifically, if you wanted to get in super detail, which our graph is not big enough to graph that much detail, you have 3 there. You don't have to write this down. 4 there. And you can imagine chopping up 10 pieces, like a decimal. That right there would be 3.5. 6, 7, 8, 9, 10, 4, 3, 2, 1, 0. So basically chopping it up into 10 little subsegments. And so right there, that's 3 exactly. 3.1, 3.2, 3.3, 3.4, 3.5 is halfway. 3.6, 3.7, 3.8, 3.9, and 4.0. That's how you would chop it up for that one decimal place. And ours was 3.3, so 0.1, 0.2, 0.3. It's about there. So again, it's between 3 and 4 for sure. It's not quite halfway, it's a little closer to 3 than it would be to 4. That's what I'm going to do. I'm going to say right about there. Looks good to me. And I'm not going to do the same thing for the y, but we still have to eyeball it. It's going to be negative 2.8. You're going to go down, negative 1, negative 2, negative 3. It's going to be between negative 2 and negative 3. These look off. And so if I did that same thing there, it'd be negative 2.1, negative 2.2, 2.3. So basically, I'm going to move this D. It's in my way. I want to say it's right about there. Can you see that? Let me draw my arrow bigger. Let me draw this whole thing because I feel like I mashed that up too messily. So let me clean this up. Negative 1, negative 2, negative 3, negative 4. Okay, I did have a point D, which I just erased, but let me put it back. It's not what I'm doing now, I'm just putting D back. That was D. But now I'm trying to do E. 3.3 is going to be there. Negative 2.8, negative 1, negative 2. I'm going to say it's about there. Close to negative 3, but not quite. But definitely between negative 2 and negative 3. Okay? And I'm just going to eyeball it. Okay, and that's it. Not whole numbers, but you just estimate where you think that is. Oh, and let me label it. That's point E. Okay, so it's getting familiar with the plotting points based on the ordered pair. I'm going to pause here and do the next problem in a bit. Okay, so the axes, the horizontal and vertical, or the x and y axes, divides the Cartesian coordinate system, which I'm going to say the coordinate system for short, into 4 quadrants is the term they use. Quad meaning 4. So basically, you've seen the Windows logo, and the Windows logo has 4 different colors in the sections of your logo. Same idea. This is chopping up to 4 areas. Because technically, these axes, even though we stop there, technically that goes to negative infinity, that goes that way, that goes that way, that goes that way. So every point is in one of these 4 sections called quadrants. And they have numbers, so sometimes you'll want to refer to where it is, and so there's a standard way of numbering it. Don't write this down, I just want to refer to our previous example. You have it in your notes. But what I want to say is point A was right there because it had a positive x-coordinate. Oh, that's wrong. 2, 3, my bad. So this was the A wave that we just did. It had a positive 2x coordinate, so it went out to the right. A positive 3y coordinate, so it went up, and it ended up in this upper right section. 2 positive coordinates. So that section of, or that quadrant rather, with a positive and a positive x and y coordinate would be a point right here or somewhere in there. That's quadrant 1. And then what they do is they go counting 1, 2, 3, and 4 in a counterclockwise direction. Clockwise is that way, and the way the clock runs, if you're familiar with non-digital clocks. But counterclockwise is the opposite direction, going this way. Okay, so with that in mind, that's not part of it. It helps me to remember the numbering. 1, counterclockwise. This one is 2, this one is 3, this one is 4. They do like to use Roman numerals, even though it's kind of obsolete at this point. But 1 is 1 I, 2 I's makes up 2, 3, and then fortunately we don't have to go too high and learn how to do the entire number system in Roman numerals. But just be aware that your 4 is an I and then a V. Now, just so you know, but if you wanted to give your answers in the form of 1, 2, 3, and 4, what are called Arabic numerals that we're used to writing. I mean, you think of them as an American number system, but no, they use it around the world, and it's called Arabic. It comes from Arabia. And you can use those. You don't have to use Roman numerals. But I want you to be able to identify where points are, ideally without graphing it. But I'm not going to lie, when you figure it out, you imagine the graph at least in your head. So these instructions will be identified, the quadrant. For the following points. So you're not graphing it, you're just identifying quadrant 1, 2, 3, or 4. Okay. The last one to hold off on because I forgot to mention. You have the 4 sections, the 4 quadrants. The axes themselves are not considered any quadrant. So if it's like a point right here, that's like on the border between quadrants 3 and 4. A point like that, you would just say no quadrant, or you could say on axis, either one. But being on the axis means no quadrant. Keep that in mind. Okay. Again, just identifying the quadrant. You can imagine if you graphed it, you're definitely not going to want to do tick marks to -81 and -62, but you can imagine which direction you're going to go in for the x and y. But we're not doing that one yet. 2, -5. I would go 2 to the right, positive 2 for x, then down, and I would end up there. And then I just imagine my quadrant system. Write it down on your paper if you have to. 1, 2, 3, 4. So that would be in quadrant 4. And feel free to just abbreviate. Quad 4 is fine. Q for I'll even accept. You can use the Roman numerals if you want. You don't have to if you don't want to. That's fine. Quadrant 4. Okay. Next, -62, -81. I'm not going to graph the actual point, but I can't imagine where I would go if I were to do it. I go -62 to the left for the x, -81 down for the y. So I end up in this area right here, this quadrant. Which one is that? Quadrant 3. Last one is, I don't want to say it's a trick question because I literally just told you how to handle it, but it is not going to be a 0.0, 8 would be right there. You go 0 along the x, so you don't move left and right, and then you go 8 along the y, which is up. It's going to be on the y-axis, pretty high up on the y-axis. What quadrant is that? It's not any. It's on the border between quadrants 1 and 2, but it's not considered in either of those. Your answer here is either no quadrant, or you can just say on axis is fine. Just don't give me an actual number because none of them actually apply. At that point, it's not considered in any of the 4 quadrants. It's on the border. Okay. I'm going to pause it there. Okay, next we're going to talk about independent and dependent variables. When you have 2 variables, like an x and a y, or again, we're going to use different letters like maybe t and p. When 2 variables are related, we often theorize, and sometimes those theories are wrong, but we won't get into that right now. We often theorize that one a change in one causes a change in the other. Okay, and that leads us to the concept of an independent variable and a dependent variable when you're talking about two variables that may be related. The independent variable is the variable suspected of causing the change. We'll get to examples in a bit, but let me get the definition down. And these are sometimes really hard to define, and sometimes it's hard to distinguish between them, even though I'm going to make you do that. I'll try to keep my examples fairly straightforward, but sometimes it's debatable, and sometimes people disagree on what depends on what. The dependent variable it's a variable, and I'm just going to keep it straightforward, that depends on the other variable. And this will be a little bit clearer with some examples. Identify the independent and dependent variables in the given scenario. And I'll give you a description, and I'll introduce actual letters to not X and Y. We're going to get away from that and start getting used to seeing other letters to denote it and distinguish it between the two. The common one is to let t be time, specifically let t be the number of years since 1980. And P, the population, or the global population, let's say that. And so there are two variables, T and P. Very common thing that we're going to be seeing a lot of T for time and P for population, because a lot of my examples that we work with to illustrate the concepts are going to be talking about population growth or decline over the years. Okay, so one thing to think of is that when you graph it, if you were to graph it, we're not being asked to graph it, but if we imagine how you would typically see this particular graph, would you put the years here? So there would be 1980, the 0 years since 1980, 1990 would be 10 years since, and 20, would you see the years there, and then the population of the world would be billions over here? If you see population graphs, anything that's graphed over time, usually you like to see the time going along here, and you can see things going up or down. The number of cases of a virus is going up, or it's going down, hopefully, or the global temperature, because of global warming, is it going up or is it going down based on the years? So you would usually see years here. And then you would see something growing over the years or something declining over the years. So typically time is independent because it just marches on. No matter what happens, tomorrow's going to be a new day, and 6 months from now it's going to be 2021, and again, time does not depend on anything else. But As time marches on, various things depend on it. The population tends to grow, the population of the world. The global temperature is increasing according to global warming. People's happiness is generally declining. That's what people say, at least. But basically, T is going to be your independent variable in this case, and you're going to graph population along it by showing it going either up or down. And T is like X, that's your independent variable. That's always going to go along the horizontal axis. And P is going to be your dependent variable. And if you want to see the graph of the global population, you would see it going up like this. And maybe we'd see it growing. But anyway, the main thing is we just identify independent variable is just T. You don't need to write that word out. The T is a variable, P is the other variable, and your dependent variable will be P. Okay, I'm going to give you another example. This one is a little bit tricky sometimes to get your head around. The number of cigarettes C smoked per day and someone's life expectancy, meaning how long they're expected to live, which they're going to call E. And these different letters for different things, but here they're using E for life expectancy, expected lifespan, and C for cigarettes, essentially. Think about that one. What's causing what? If you live long, does that cause you to smoke more? If you live short, does that cause you to smoke less or something like that? Or is the amount that you're smoking causing changes in your life expectancy? What's causing changes in what? Okay, so your life expectancy doesn't cause you to smoke a certain amount of cigarettes per day, but according to health experts, the number of cigarettes you smoke per day does cause changes in your life expectancy. Your life expectancy essentially depends on your health habits and specifically how many cigarettes you smoke per day. So you're independent, C, you just smoke as much as you want, but then your dependent variable depends on it. If you smoke too much, your lifespan in theory will go down. And again, it's a theorized relationship. Maybe it's false, maybe it's true. We're not getting to that. We're just making sure we can identify the theorized relationship where the number of cigarettes you smoke will cause changes in your life expectancy. Your life expectancy will depend on how much you're smoking throughout your life. Okay, and I'm going to pause it there. Answer this time. Okay, next we're going to talk about scatter plots. Our book actually calls it scattergrams, but it's the same thing. Scatter plots being the more common term, so I'm going to stick with that. A scatter plot or scattergram, I'll mention what the book uses in case you do refer to it, same thing, is a graph of ordered pairs basically some points to display, but this here we're going to start talking about context, to display the relationship of two variables. Okay, let's do one. Let A be the age in years of a child. and H, no, and W. Their weight in pounds. Pounds abbreviated by LB. Okay, so you're going to have a table. Sometimes it's given vertically where you have your X and then Y, but if they change the letters, then it's going to be different letters. But the first, and it'll always be like this where the first one in the top row or the left will be like X and will be therefore be the independent variable. And the second variable in the second row will be the Y variable, or the second column will be the Y variable. I'm not going to try and trick you by switching it up. You're always going to treat this like X and that like Y. But here you have to know the context. The age is, A is the age, so it's 3 years old, 8, 11, and 15. So we have data from these 4 ages. For some reason they weighed this kid only at those particular ages, and they found out they weighed 32 pounds at age 3, 47, 89, and 103 pounds. Create a scatter plot for the data. Then actually I'm going to put all these parts. Sketch a line as close to the points as possible. Then C, use your graph. This is something we're going to actually do in lesson 12, but we're going to get a preview of it now, get you familiar with it. Use your graph to estimate the weight, or their weight rather, the kid's weight, at age 5. Okay, I need space, so I'm gonna leave that on the bottom, and I guess I'll clear out this definition and start doing this scatter plot. Now, in my original homework set for this lesson, you just had some graph paper. It was attached to your in the file. You'd have to buy separate graph paper, but basically it was a whole page stapled to the rest of your homework that had just a grid in it. And what I had you do was create and scale your own set of axes for this. So I'm going to illustrate that now, even though because we don't all have graph paper, I can't make you actually do this at home, so you're not going to be doing it. But I still want to go over it. So the idea is you just have the graph paper that you're working with, and you have to basically build your set of axes. So I'm going to talk about that, then I'm going to erase this and then just do it without the graph paper aspect of it. But I do kind of want to talk about this part of this lesson in creating your own axes and scaling it properly, because people do have difficulty with this, and it was an important aspect of it that I just can't really do the same way I would be doing it if we were doing face-to-face classes. Okay, and to make it clear, I'm going to do it in red, but the idea is I need to make my own axes. Now, up to now, I've been making axes showing all 4 quadrants and kind of dividing it equally. But when I start plotting these points, you'll notice they are all in quadrant 1. 3, 32, 8, 47, wherever they are, they're all in the first quadrant, meaning I'm wasting all this space and all this space and all this space if I do it like that, where I cut it down the middle and then across the middle. So I want to take advantage of the fact that I want to use my space wisely. So there's no reason for me to show quadrant 2, quadrant 3, or quadrant 4. And I can just focus on quadrant 1, So therefore, to make good use of my graph paper, I'll just make my vertical axis along the left, my horizontal axis along the bottom. And now I'm using all that space for the first quadrant because all my points are going to be in that first quadrant. The next thing you need to do is label this, and again, your first variable is like x, your second variable is like y, and if they didn't give you the data in this form, you have to make a distinction between the independent variable, which is like x, independent goes along there, dependent variable goes along the y. So the kid just ages along, but based on the ages, the weight depends on the age. So if I was asking that question, age independent, weight would be dependent. And now I can't just do, I don't want to definitely do 1, 2, 3, 4, 5 necessarily. Definitely not along the W because I'm not going to be able to get to a weight of 103 if I just use these tick marks, these spaces as 1. 1, 2, 3, 4. Even on real graph paper, you're not going to be able to get to 103. It's just going to be a lot of writing of little tick marks and counting up to 103. So we're going to skip. So just to give you a preview, but I'm going to do it on the graph paper. The ages go up to 15, and what I can do is, instead of going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 15, I can just jump. And usually you want to do by even numbers. So maybe I could go by 3s, 6, 9, 12, and get up to 15 in that way. So I'd be going by 3s. That's valid. More commonly, they'll do some nice round numbers like maybe 5s, or 10 sometimes. Maybe even 20, but maybe I could do that. Maybe I could just do 5. And if I did that, I only need to make 3 tick marks, 5, 10, 15 to get up to the end of that graph. Okay, so let me think. I'm going to do what I talked about earlier, going by 3s. For no particular reason, but in that homework, you would have the option on doing it how you want. Can I do that? Okay. So I'm going to go by 3s. I'm going to go 3, 6, 9, 12, and to 15. Now I don't want to necessarily just make the first tick mark here and do one block and call that 3, because then I think I'm going to be wasting space. What I mean by that is, I'll reach the end, my furthest right point, the 15, 103, wherever that is, right over there, and I'm wasting all that space, half my graph paper. So I don't have to make a tick mark at each of these blocks. I can choose to make my tick marks every 2 blocks. So I'm not going to have a tick mark there. I'm going to have here, my first tick mark there, 3. I'm going to skip the same number. I'm skipping 2 to make a tick mark. 2 blocks and another tick mark. 2 blocks and a tick mark. 2 blocks and a tick mark. Let me pretend I have more space. 2 blocks and a tick mark there. And let me see if that gets me there. 3, 6, 9, 12, and 15. That's a little bit better because now I'm making use of my space. So that's good. I feel like that's a good way to do it. Again, I'm making 2 blocks and a tick mark, and I'm calling each tick mark 3. So it doesn't have to match up. You don't, again, 2 spaces in my graph is equal to 3 years of age. 2 spaces for another 3 years of age, 2 spaces. As long as I'm consistent. If I had more graph paper and a bigger graph paper, maybe I go every 5 blocks, 3, 6, 9. So you would scale it based on how much space you have, how fine the blocks are, but the main thing is you need these to be the same width from tick mark to tick mark, and need to represent the same number of years. They don't usually label the origin, but that is like a 0 years old, 3 years old, 6 years old. Okay, so I'm going to go with that, but again, they don't usually label the 0. Now let me talk about my vertical axis. I got to get to 103. I think I'm going to go by 20s. So I'm going to go by, if I go 10, I got to go 10, 20, 30, 40, 50, 60, 70, 80, 100, 90, 100, 110. And that's kind of a lot. But if I jump by 20s, I can go 20, 40, 60, 80, 100. And I definitely want to go to the next tick mark above, since that's slightly above. So I want to go to 120. Okay. Yeah. Okay. So it looks like I can't, if I go 22 blocks, 20, 40, 60, 80, I don't have enough. So I've got to use less blocks. A lot of this is going to be erasing, writing in pencil. If I go one block, 20, 40, 60, 80, 100, 120, a little bit extra space at the top, but I think that's good. So I'm going to make it 20, 40, 60, 80, 100, and 120. And that's a good use of my graph paper where I can spread out the points. And again, be aware that your ground level is 0. That's 0 pounds. And this first tick mark is there 0 years of age. But they usually don't write that. It's assumed to be 0, 0 at the origin. But you can write it, I don't mind. Okay, anyway, that would be an exercise in scaling your axis. I'm going to mention one thing. I'm going to go back to this one. It was good. I'm erasing it to show you something that's bad that people do a lot. And I just want to address it, even though you're not going to be doing this and probably forget it. If you ever move on to another class and you have to graph things carefully, I'll mention a common mistake. So that whole idea of going 2 blocks being 3 years of age is probably good, but a lot of times people will put their first tick mark right there, 1 block away, and then they'll start skipping every 2. So they're going to go 3, 6. This happens so much when people turn in their homework in a face-to-face class. Okay, and I would mark it off because this is not consistent. It's consistent here. 2 blocks for 3 years of age, 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 except for that first step from 0 to 3. For some reason, they're not consistent with that first step. It's 2 blocks for each tick mark the whole way, except for that first tick mark. They only put 1 away from the origin. So right there, I would circle that, and I would say inconsistent scaling, or how am I spelling this? Inconsistent scale. And since I would be doing corrections, I would turn it back to them and let them make corrections. And they'd have to basically erase or get a new graph paper and redo it, because that is not acceptable for them to be inconsistent there. So the key thing that I would be really trying to stamp out is that tendency to be inconsistent with your tick marks. Okay, but again, we are not going to be doing graphs because we're all at home and not everyone has a printer. But just be aware of that. Scaling of this is important. Let me put it back. I'm still going to do part A. I haven't done anything yet other than scaling my axis, which is a crucial first step and probably the trickiest of them all. But let me real quick redo what I had. I want 2 blocks. I got to be from the start. 2 blocks and 3. 2 blocks and another 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 3. And that's a consistent scaling. That's perfectly fine. Okay, I'm ready to plot these points, and I would just estimate where things are. 3 is obviously there, but 32, I gotta eyeball it. 32 is about halfway between 20 and 40, so I put a point there. 8, I don't see an 8, but if I had it, it would be 7 and 8, so 8's about there. It's not halfway between 6 and 9, because I got 7 and 8. So I want to say it's about there. I'm not putting tick marks there, that's just me indicating I'm going to put it about there. 47. Just short of 50, which is halfway between 40 and 60, so because of the way I did my scaling, a lot of these I have to eyeball. There, that's 847. You don't have to label these with letters or even the coordinates. I can see that this is a 332, 847, 11 next, that's 10 and 11, so it's about here. And 89, that's about close to 90. Which is halfway between 80 and 100. Last one, 15, exactly on there, and 103, just barely above the 100 mark. And I want to place it there. Okay, and that's a scatter plot for this kid's weight over the years as they age. Then what we're going to be doing in the next lesson in particular is drawing a line to show this kid's growth, and then we can make estimates off of it. What we're going to be ultimately estimating is the weight at age 5, and there is no data on 5 years of age. It's about here, but we need to basically see how the kid's growing, and that's what we're going to do. Is we're going to be putting a line on it called a linear model. We'll talk about that term later on. The whole next lesson is going to be on linear models. But for now, you would just get a ruler, a big ruler, and you would just estimate it. You don't want it to go like that, because obviously that's not following the kid's actual weight. You don't want to do a zigzag, because you don't just want to connect dots. That's not what you're doing. We're doing a single straight line, close to the points as possible. It may not hit any of them. It might go right between them. So when I do this with a ruler, it might just miss them all. But that's the closest going to it, and that's the best. That's one of the better ways to show the kid's growth. He's a little bit, or she's a little bit heavier than our blue line. They're a little bit lighter than our blue line. But it shows generally how fast this kid is gaining weight as they age into puberty. Okay, so this is going to be called a linear model. And so that's part B. We're done with part B. And the idea now is we're going to use that graph, specifically that line, to estimate the weight at age 5. We're going to be doing more of this in the next section mainly, but we're going to preview it now. Here's 4. Here's 5, right there. And we would want to look at that line showing the kid's growth. And right there, right at age 5, that's where his weight should be, or we predict it'll be based on that blue line. And then we just go over, and because these are hand-drawn graphs, sometimes our estimates will be different. You want to estimate what that is? It's a little bit above 30, but you could say 32, maybe 35. So a lot of this is estimating, and I would accept 32, I would accept 35. I wouldn't accept 30 exactly because I feel it's a little bit above. I definitely wouldn't accept 50 because it's not, 50 is nowhere near there, but somewhere around the 30-somethings. Also, you get marked off if you don't give me units. What are these 32 representing? Oh, I forgot my A. I forgot my A is age in years. I erased it earlier, but weight is in, sorry, W is weight in pounds, and that 32 is 32 pounds. That was the estimated weight. So make sure you throw in those units. Okay, and that's kind of what we're going to be doing in the next section. I'm going to pause it there. Next, we're going to talk about a thing called cropping. And we're also going to use this example to illustrate this concept about a reference year, the T being the number of years since. Last time I did T is the number of years since 1980. Here it's going to be since 1990. And V, the value of a home or a house in thousands of dollars. Ooh, I wrote this too big. I'm going to need to erase. Year, 1993, 1998, we'll keep it short, just to illustrate this general point, 2001, and 2005. Value in thousands of dollars, it'll be 312. 292, it's declining in value for some reason. 284 and 281. Just slightly declining in value. And just do one part, create a scatter plot for the data. Using the variables as defined up here, T and V are what we're using. And there's one thing, mainly this is going to be cropping and also dealing with the reference year, two separate things I'm going to talk about in a bit. Okay, and I'm going to do a wrong graph that I'm going to have to fix, and then I'll erase and make room for a bigger graph later on. But let's talk about a few things. So this is going to be a rough sketch of what I want to do. First of all, on your actual homework, if you were doing face-to-face class, you just have blank graph paper. You'd have to scale your axis appropriately and whatnot. We're not going to do that here. We're just going to jump to pretending we have a set of axes already. Still, first quadrant we're focusing on because none of these data values will be negative, so you don't need to show quadrant 2, 3, or 4 and waste paper. Use your graph paper to show only the first quadrant. And now, you're going to have T and V, the value of a house, T the number of years, or essentially time is what it's standing for. And your independent variable goes along here, and that's not going to be the value. You're not going to see the value go along and time then going up or down. You're going to see time marching along, independent of anything else, and population or the value declining or anything like that going or occurring over time. So V is going to be your dependent variable. The value of the house depends on what year you're talking about. Okay. Now, even though this is T and we see years here, we need to note that T is defined to be a very specific thing. The number of years since 1990. So a lot of times they'll have a reference year, sometimes also called a base year, a reference at a point in time. So it's going to be the starting point in time, T0. And so we're not going to be putting years along here like 1990, 1995 or anything like that, because we want to see T values there. T is the number of years since 1990. So 1993. How many years has it been since 1990? 1993, 1990. It's been 3 years since 1990. And that's a T value. So for this particular year, with a value of 312, your T value, the number of years since 1993, the number of years since 1990 is 3. I'm going to do all my T's now because we're going to be plotting T's. What's the T value for 1998? How many years has it been since 1990? It's been 8 years. So again, we're starting with this is year 0, and then 3 years later is T is equal to 3. 8 years later is T is equal to 8, and so on. We're going to fill in all those T's. Now, as they get up there, we may not be able to do it mentally as easily, so let me just mention how we're doing it. Well, let me go through this. 2001 will be 11 years, and if it gets too high where you can't do it mentally, just know that what you're doing is you're taking this year, 2005, and you want to figure out how many years it's been since the reference year 1990. You're basically finding the difference between the two. So you're going to be subtracting the reference year. You can do that on your calculator if you want. If they start to get trickier and not as obvious and not easily to do mentally, that's going to give you 15. So that's a T is equal to 15. Anyway, so now we're going to ignore those years, although we need to be conscious of it, and we're going to graph 3, 8, 11, and 15 along that T-axis, because this is T's, not full years. And 0 is going to be there, and I'm going to look at my blocks and do it consistently, but I think I'm going to go by 3's again. 3, 6, equally spaced, same number of blocks if you have graph paper, 12, 15, 18, and that's a good use of my space. Okay, and then 312, 292, 284, 281. So I need to basically get past 312. I'm going to do it kind of half-assed. I'm going to go by 50s real quick for no particular reason. 50, 100, 150, 200, 250, 300, and then 350. Okay, and that's a decent scaling right there. Equally spaced 0 to 50, 50, and I'm going to do the same amount of blocks, equally spaced tick marks. Now, I may graph it, but I'm not going to erase because I want to talk about why this is not going to be a good graph. Okay, 3 and 312. 8 and 292. 11 and 284. And 15 and 281. All of these being very close to 300, a little bit below 300. Oops. Then my model, my linear model, my line that's showing the decline in value of this house would look like that, maybe, something like that. But the main thing here is, that's not a good graph where all the points are crammed up at the top and you wasted all the space. You're wasting all that space, and because of that, you're not really showing details about that decline in value. It's not really obvious how fast it's declining, because all the points are jammed up at the top. Because the house value never goes below 250, it never drops to like in these range. So you don't really need to show all this. All of this, let me erase that. All of this, the house never see, oh, maybe not there. Well, let's say there. The house is never gonna hit $200,000, at least not in these years, anytime soon. So we don't really need to see the graph of $50,000, $100,000, $150,000, $200,000. So just like when you crop out your ex-boyfriend out of your pictures on Facebook, we can just crop out all this space. Just cut it and just eliminate that. So we're going to do that. I'm going to leave this up, but I'm going to erase over here and show you how a cropped graph would look. Okay, my horizontal axis needs to show all the years from 3, 8, 11, 15. So it wouldn't be helpful to crop off, I need to see from 3, it wouldn't be helpful to crop off 0 and 2 because that's only a small amount of space. So there's no need to crop this part of the axis. Sometimes you do, sometimes you crop along the horizontal axis, but not this one. Our points start here and go all the way to here. So that's a good use of our space going this way. We're going to point there, we're going to point there, and definitely that's a good use of space. But vertically, you're wasting all that space, and we're going to crop that out. So technically you're supposed to show a break. They don't always do, but they show some sort of a break. Sometimes they make it a zigzag, but basically, imagine chopping all this off. Right there, cutting all that off. And then just stitching it back together. So I'm going to do the break, but the zigzag is fine. A break in the axis, let me label that for your notes in case you're taking it, even though we're not doing this because we don't all have graph paper. Break in axis is what I'm going to say. And so my first tick mark doesn't have to be 50 anymore, I can just jump to a tick mark that was higher up. I don't want to go to 300 because I don't, I want to show the 281s and 284s which are below that, so I'm going to start at 250. I'm just going to jump to the 250 mark. And that doesn't mean I need to go to another 250 and another 250. It means I can scale from here the same way I did over there, the same spacing. Or even larger spacing to make more use of my space. What do I have, by 50s? Okay. I don't even have to do by 50s anymore. If I'm looking at details, it's only going to 312, so now I can rescale it as I see fit. I have all this space, and I don't want to go to like 300, 350, 400, 450, and 500, because it doesn't even get close to 500. I can scale it differently now. Maybe I'll go by 20s, 270, 290, 310, and 330. I think that's good. Again, you would be doing it on your own and you might scale it differently. This is not the correct answer. It's one of many acceptable ways to scale this. Notice those tick marks are 20 apart, 20 apart, 20 apart, 20 apart. It's not consistent from here to here because that's a 0 there, that's 250, but that's not, there's a break there. There's a part of the graph that's just completely chopped off, and you show that with a break, and people are fine with that. And now you can plot your points. This is me just illustrating the scaling. And now I can plot 3 and 312, right about here. 8 and 292. 11 and 284. And 5 and 281. Sorry, 15. My bad. 15 and 281. Oops. And that's a better use of your space rather than remember what this graph looked like. If I did the full scaling on the full axis, all the points were crapping on top of the graph and you wasted all that space. But here it's making more use of your space. So that's what the cropping means, and it is something I would have made you do for homework if everybody could just, I could just hand out printouts with a graph paper, but since we're all at home, I'll have to cut it short. So this homework's going to be short, even though the lesson was a little more extensive. But a lot of this will blend into the next section, which can be tricky. So look out for that.